different problems and talking about percents, and we showed how we could use proportions to solve them. And those are not the only way to solve those problems, as you're well aware. There are other ways in addition to those. However, those proportion ways of solving these problems are really nice because they're easy to set up, and that's a really nice feature about them is the ability to set them up. A lot of times your students, as well as perhaps you, look at a word problem and you feel like, I don't know how to set it up. If I could get it set up, I could probably solve it, but I don't know how to set it up. And proportions are really nice because they make it easy to set something up. So the last thing that this section that we're going to be taking a look at is the mental math stuff. And, or the last two different things, one of them is mental math. So the first thing I want us to take a look at is how mental math percents relate to fractions. So the percentage, 25%, what is that as a fraction? That is 1/4. Think in terms of quarters, right? There's 4 quarters, and a quarter is worth 25%, so there's 25 cents, and there's 4 quarters in a dollar. How about 50%? That's 1/2, and 75%, that's 3/4. So every time I look at those percents and those fractions, I always think money. That's what my mind does. I think money. The next two are actually really nice as well. We've been working a little bit with this idea of 33%, 66%. We talked about this at the beginning, but we didn't do it in terms of percent. What is 33 1/3% of a fraction? That's 1/3. That's exactly 1/3 of 100%. And how about 66 2/3%? That's 2/3 as a fraction. What is 10% as a fraction? That is 1/10. And 1% is 1/100th. And there are different instances where those are really nice factors, or fractions rather, to remember. And a lot of times it has to do with shopping. We see things like the lemons example that you were talking about there, right? Where we see something where it says $2 for 3 lemons. Okay, great. That sounds sort of strange because I did some divide evenly. How does that relate to a fraction? Well, we also see things sometimes where there's something to say, it sounds like 1/3 off. What is 1/3 off? Or equivalently, it'll say something like 33% or 66% or whatever percent off, and how does that relate to a fraction? Because there are instances where fractions are easier to work with than percents. So we're going to take some examples of how to do mental math. I created these examples, and I perfectly well realize that mental math means you do it in your head. I can't see what you do in your head, so you have to write down for me what your head did. Okay? Literally, what did I do in my head? That is, write it out in words. Okay, so this isn't going to look like an equation necessarily. It's going to look like, a couple sentences maybe. Make sense? So if you were looking at finding 15% of $42, how would you do that? Literally, what would you do if you were asked to find 15% of $42? Yeah, that's what I do too. I find 10% first, and then how would you find the other half? Okay. All right, so let's literally write down what we're going to do in terms of numbers. So first, you said 10%. So what is 10% of $42? $4.20. And then, so this is what we did. We found 10% of 42, and that is, or as $4.20. And literally, you did not multiply by 10%. What did you do? Really? You just did the decimal point, right? That's literally what you did. And then, what you told me next, Audrey, was what? And then we find 5% by dividing the 420 in half. Yeah? Because 5% is half of 10%. So what would that be on this number? 210. So then we find 5% by halving, or dividing in half, the 420, which is 210. Then what would we do? Then you add together. There's no subtracting. You just add them. Yeah. And add 420 plus 2. I dare say you're really bright to that down. You should be able to do that in your head. These numbers have to be really pretty and nice, right? And literally, one of the places we talked about before where you use percentages like 15%, a lot of people use that when they do tips. 15% is a tip amount at a restaurant. So if you're like my grandparents, they really do get a piece of paper and a pencil out and they add this literally up. Okay? They lived through the Great Depression, they think differently than I do. Right? Most people do some sort of rounding, right? They kind of look at it and say, oh, it's a $32 whatever, so I'm going to round this to whatever, and then I'm going to figure out my 10% and my 5% add those together. Or they might have some other method. So I don't actually do this. I actually run the tax. So I do when I go to the restaurant, then I round up usually in there. And be careful with that. That works fine in Oklahoma because the tax rate in Oklahoma is kind of high. It's 8 1/4, 8 3/4, or depending on where you are. If you're up in Ohio, the tax rate is around 6%. Don't worry, they take your taxes anyways. But the tax rate is around 6%, so if you're not being careful, you could actually undertake what you thought you were doing. So I have to be really careful when I'm in a different place than where I am normally. But anyway, this would be a good way of doing 15%. All right. Let's do another. How about 20%? What would you do for 20%? But that we can do. You could, right? Because 20% is actually the fraction 1/5. So you could take the number if it's nice, and this one's not too bad at 280, and you could divide by 5. Absolutely. How else could you do it? Yeah, so you could actually do 10% and then just double it, right? So I'm going to go with that one, not because the 1/5 won't work, but because you have to be a little more careful that the number works in this, right? So it works really nice, no matter what the number is, to figure out what 10% is. So what is 10% of 280? What is it? 28. So we found 10% of 280 is 28. Then what? Then you can double it. Then double 28. So 28 times 2 gives me 56 dollars. So maybe you're a generous tipper and you took 20%. I have a sister-in-law who takes 30%. It's a good term, she'll take 30%. Yeah, people do. And stingy people are on part C. Maybe it was just really bad service, I don't know. Or maybe you've got something worked out that you need 5% of the number in some other context. Okay, so how could you do 5%? You kind of already did it, right? You would find 10% and then cut it in half, right? You do that, yeah. So what is 10% of $28? This would actually be $2.80, right? So we've got a $28 meal. This is $2.80. So we found 10% of 280 to be, sorry, not 280, it was 28. 10% of 28 to be $2.80. Then what? You guys told me it what? We're going to half it, right? Because we want 5%. Half it. So cut it in half to be what? 140. Maybe you're offering somebody 5% commission for something that they're doing for you. Like every referral, lots of places do stuff like that. If you send referrals our way, we'll send you, a gift card to our restaurant or a gift card, especially if it's starting out. They can offer incentives that way to get their name out there. How about 25%? Cumbersome to kind of keep the same pattern up, right? I'd have to find 10% and double it, and I find 10% and half it, and be okay. So if you like that way, you want to write it down, that's wonderful. But it becomes a little bit messier just because there's more dividing and multiplying to do. There's just more steps to it. And so especially if the numbers are nice, kind of like what you were doing with the division by 5 before, Sarah, the number's nice, which is really is very nice. Divided by 4 is great because the fraction 1/4 is equal to the fraction or to the percentage 25%. So we could simply divide 84 by 4. And what is 84 divided by 4? What was it? 20 something, 21, yeah. Let's try that again. So you get 21. We do 84 divided by 4 Again, none of those are the only way to do that problem, right? But whatever it is you're thinking mentally, but it has to be something you can do mentally. So, for instance, the first one, 15% 42. If you tell me I'm going to multiply 0.15 by $42, that is not an acceptable answer for the directions. The directions you're supposed to do it mentally. And I don't think you're going to be multiplying 0.15 times $42 in your head. It's not reasonable, okay? But if you answered this part B, D here by saying that you're going to find 20%, by finding 10%, doubling it, and halving and adding, that's okay. The numbers are small enough, they're reasonable enough to work with. You probably do that in your head, okay? But you have to write down for me what it was you did in your head. Yeesh. Let's see what else we've got. Does 0.4 equal 4.4%? Why not? Well, it doesn't actually matter. But I think it's 4% of the right. That is true. We think of percentages like that, 4% of something. But I just want to be able to take the number as a decimal and write its fractional percentage, or a decimal and write it as a percent, or a fraction and write it as I want to be able to move back and forth between these kinds of numbers. So one of the ways to explain that these aren't equal would be to actually show what you should be getting. So let's either take the percent and turn it into a decimal, or take a decimal and turn it into a percent and find out what it should be. Okay, we don't need to do both of them. You pick one way or the other. So which one do you want to pick? Decimal. Okay, now since I should take the decimal, how would I turn a decimal into a percent? Multiply by 100, right? So 0.4 times 100 is what? 40%. Big difference. So if somebody's going to give me a 40% income on their product, we're promoting their business versus a 0.4% income, I'm going to feel real chipped if they go the other direction, right? That means something different. So this is equal to 40%, not 0.4%. 0.4% sounds an awful lot like the interest rate in the savings account right now. Very, very, very small numbers in your interest rate in your savings account. Okay? That's not like how it is right now. Whereas a 40% sounds like a sale at Kohl's. 40% off going on. Okay, so here's an example on number 8. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? So it might be helpful if we talk about price. Okay, so let's say that you have a $100 dress. It's amazing. You want it. Okay. Well, here's the deal. The $100 dress. If we took the $100 dress and we increased its price by 150%, what would that turn into? I had a $100 dress, and I want to increase the price by 150%. What would that be? Okay, the increase would be 150, which means the total price would be 250, right? So the increase is 150. That's my increase. For a total of a $250 dress. So this is what merchants will do right when they buy their product. Okay? So Old Navy buys their product from whomever overseas, probably China, somewhere, I don't know. And then they have it shipped here, and then they have to do an increase in the price to cover the cost to get it here, the cost of labor where it was, and all these things, right? They have to have a markup, otherwise they don't stay in business. And we need them to stay in business, otherwise how are we going to get our clothes? This is going to be a problem. Okay, so there has to be a markup, because otherwise if they don't make a profit, we don't get to shop there anymore. That's the way marketing works, okay? So that's great. I could definitely increase the price 150%. I just did it. Why can't I decrease it by 150%? They would pay me to take the dress, and then they would go out of business, wouldn't they? Yes, that would not be good. So if I tried to do the same thing, to do a decrease, I could literally do the same thing, right? I could take my $100 dress, and I would decrease it by 150%. I would end up with a negative dollar amount. And the issue is, of course, I can't have a negative cost for the product. So I can increase the price of something all day long. Okay, that's what we talk about middleman here. We talk about cutting the middleman, right? They cut out one of these steps of somebody increasing the price, and it gives you a better price. This is why the internet's so popular for purchasing different things, because it cuts out middlemen a lot of times, right? You buy it straight from that person making that crappy pot holder. You don't have to buy it from somebody who bought the pot holder from them. But you can only decrease the price to the point where you would be giving away nothing, even zero. So the most I could decrease the price would be 100%. In my entire value of the item is I can just pay nothing. Which is what we would want either. It's not helpful to our business. All right. So you guys have seen this equation before. I will tell you that this equation at the bottom for compound interest is not the one your book uses. But I'm using this one because this is the one that you're probably the most familiar with seeing other textbooks. We're going to use the one you've seen before, okay? So interest is the amount of money you either pay or earn to borrow or lend money. So you have two different kinds of ways you can talk about interest. You can talk about the interest the bank pays you because you have an account open with them, right? Savings account, those kinds of things. Or you can talk about the interest that you pay because you borrowed money for some purpose. Maybe it was to purchase a car or a house or school loans or something like that. There's interest the other direction for money when you borrow. Okay? Principal is the original amount used to determine the interest. So it's the original amount you put in that savings account and never touched again. Or it's the original amount of money you borrowed before you had to start paying it back for the car or whatever. Interest rate is the percentage used to determine the interest. So again, the savings account interest rates, they're small. I remember when I was probably in high school, junior high, whatever it was, I got my first savings account by junior high. And the interest rates on savings accounts were like 3%. That's pretty typical, and it was no big deal. Interest rates now, I'm serious, I think the interest rate on my kids' savings account is like 0.25%. I mean, it's virtually nothing, especially for as little money as children put in the bank anyway, I mean, realistically. Okay, so the interest rate's really small. Okay, on the flip side, the good side right now about what's going on too is that you can get car loans or house loans at rock bottom prices. They're great right now. So if you're in the mood to go get a loan for something that you need money for, you're not going to pay as much in interest as you paid when my parents were doing this when I was young, right? And your parents when you guys were young too. So that's the interest rate. And then there's two different kinds of interest. There's simple interest and there's compound interest. Okay? Simple interest has these sort of simpler formulas. What you'll notice in these simple interest formulas is that there's no exponent, right? Which means they're easier to work with. That's actually a plus. But simple interest is typically the kind of interest that your parents might charge you if they're trying to teach you a lesson, right? They're going to teach you the lesson that when you borrow money, it costs you more to pay it back. And this is where you kind of see simple interest used. Compound interest is the kind of interest that you see used when banks just do things. So what compound interest does is it does for interest rate every time like monthly. So as a common way to build your interest rate or quarterly or something like that. And they give you all the interest or they charge you all the interest on on either on the amount that currently resides in that account, or the amount that you currently owe on that account. Okay? So we're going to do a couple of different examples for what happens, but again, notice that if you look in your book, it doesn't show this formula. It's an equitable formula. They do it a little differently. And it's not just a matter of different letters either, so. All right, so here's a company. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest must the company pay? Okay, so this is something where they're probably borrowing it from someone who's investing in their company. And so you invest in my company, Jennifer, and then in 18 months, I'm going to give you your money back with 13% to 13.5% more. Okay, so this would be a simple interest situation. And it says it's simple interest, right? Simple interest. And it asks you how much interest must the company pay. So there's simple interest formulas are on the line before. And one of the simple interest formulas, it doesn't matter which one you use, looks like this. Okay. A is the amount that they'll have to pay at the end of this time period. P is the principal, the amount in this case that they would be borrowing. R is my interest rate as an annual interest rate. And then T is the amount of time. And I need to tell you that T in time is always in years. So this T is not 18. What is it? 1.5. T is always measured in years. So A is what I don't know. It's not exactly what I'm looking to find, but we'll deal with that in a minute. But it's something I don't know right now, which they owe back at the end of this time frame. I do know that they're borrowing $320,000. We have 1 plus. The interest rate is always the interest rate as a decimal. And that's one of the reasons we need to be able to move back and forth, kind of like what we were talking about, Sarah, between that fractional or that decimal form and that percentage form. So 13.5% is not the same as the decimal that we need it to be. What decimal is equal to 13.5%? 0.135, right. Okay, so you have to take this and turn it into a decimal, which means moving the decimal 2 to the left. And then again, like I said before, the time is time in years, and that's 1.5 in this case. Okay? So I expect you to see this written out. I expect you to write this out. Okay, after that, if you want your calculator to do the multiplication stuff, I'm okay with that. But I want to see that you're putting the numbers in the right place. That way, if you did, in fact, accidentally write down 18 instead of 1.5, I know what point it is that you're forgetting something, where you're making a mistake, and I can let you know that. Okay, so somebody's going to tell me what they get when they take 320,000 times 1 plus 0.135 times 1.5. Another thing you can do in your calculator is you work from inside out. So you can take your calculator and you can multiply the parts that are right here. So you can take 1.135 times 1.5, hit enter, hit plus 1, and hit enter, and hit times 320,000 and hit enter. It keeps you from making mistakes with your parentheses, which is sometimes really easy to do depending on how careful you are. Did you get a value, Jennifer?
Try. Really try everything quick.
Yep.
384,800.
Okay, so this is the amount that they owe back. But again, that's not exactly what the question asked, right? The question asked, how much interest must the company pay? So how can I find out how much interest they must pay? Yeah, the 384,800 that we just found minus the 320 that they borrowed to begin with. All right, they're not really paying 320 back. They borrowed that to begin with. That's just reimbursement. They didn't pay that amount of money for using their money. They just used it for a little while. And if we do that, what do we get? $64,800. So for the risk that you were willing to take in my business, Jennifer, you get these $64,000 in your hands. It's not too bad of a rate of return on your money, but what if I belly up my business? Bye-bye, $320,000, right? So there's risk involved, and that's why you get that benefit for having taken that risk. Okay, let's take another one. Johnny and Carolyn have 3 savings plans, which accumulated the following interest for 1 year. number 1I is a passive account made at $53.90 on a principal of $980. Number 2, a CD made $55.20 on a principal of $600 rather. And number 3, a money market that made $158.40 on a principal of $1,200. Which account paid the best annual written interest rate for 1 year? So we're going to try and figure out which one paid the best rate. So we can actually find that, and we'll do all 3 of their interest rates and compare. So how would we find our interest rates? Well, that's not directly related to the equations that I told you before, but what we want to know is we want to know if this amount of money, given this invested amount of money, is a good deal or not. And so the way that we do that is we actually do a division problem. We decide if the amount of money we earn versus the amount of money that we put in ends up giving me a higher or lower percent versus the other ones. So this is $53.90, and this is given an interest or given an initial investment of $980. Okay. Sarah, can you find out what that decimal would be for me? 0.055, and then what would that be then as a percentage? Right, so this is a 5.5%. Number 2 was $55.20 compared to a $600 investment. Do you want to go this one, you mind? Sure. Okay.
0.092.
0.92, which is a 9.2% interest. So that one's my leading value now, right? Number 3 was $158.40 for a $1,200 investment. 0.132, which is 13.2%. So which account had the best annual interest rate? The last one, so the money market did. So make sure you answer the question. The question asked which one, the answer is the money market. But all your work that I just did supports that that is the correct answer. So you need to show all of that in order to get there. Okay. We have 2 more examples. The next one's not exactly interest. It's not really about money, but it follows the same form. So it kind of gets lumped into here with this as well. It says if a publishing company signed an agreement to allow a textbook, the textbook has the first edition 500 pages, to expand over several editions. Okay, so it's going to get bigger. So imagine a history book, okay, or something like that. Math doesn't really do this. Some textbooks gradually get bigger as they add more content or expand more content over time. That's what's going on. And it says that it's going to expand until it gets to 1,000 pages, and at that point they're not going to have the same relationship between this company and this textbook publisher anymore. And it's growing at approximately 10% in the number of pages over each edition. The question is, how many editions could be published before it reached the contractual limit? So how many times could they increase it 10%, in other words? Make sense? Okay, so there's several ways to handle the problem. We're going to handle the problem from an equation point of view first, and then I'm going to show you from a table point of view how you can think about it. Okay? So there's just a couple of different ways to do it. Let's talk about it from a point of view from this equation. Now, the equation doesn't exactly fit, but we're going to talk about it and how it can be used. Okay? So this A right here and the P, that has to do with the page numbers. P would be the initial size of the first book, and then the A would be the size of the book when it's actually finished and we're not going to produce it anymore. Okay, so that's the 500 and the 1,000. Kind of like the money in the account, right? You put $500 in the account and you want it to grow to $1,000, right? So this is how we're treating it, very much the same way. We've got the 1 plus. The R in the end is the interest rate over time, and it actually tells you, in this case, it's not an interest rate, but it's the growth rate of the product. And what is the growth rate of the product? 10%. 10%, and 10% as a decimal is 0.1, okay? And the n here is actually talking about how many times it does this per year. This is the n, or this in this particular situation is how much it's doing per addition. So it's growing 10% every addition. So it's kind of like having 10% over 1. The n is the addition number. One addition grows 10%, okay? And again, up here, this n is like the number 1. So if we simplify this, we have 1,000 equals 500 times 1.1 to the t. Okay? Now, I'm not interested in us solving this with algebra. That is to say, I'm not going to use, what you would do is literally is you would use logs to pull that t down. Some of you had enough math, you know what I'm talking about. If you don't, it's okay. That's not what we're interested in doing here. What we are interested in doing is grabbing your calculator and trying out some different values for t up there. You want to find the largest value for t. Okay? T in this case is not really the amount of time, it's the number of times this book gets to be produced. Okay? It's a little different. You want to try some different numbers for t to see how many times you get to reproduce this book. Obviously, it's more than once, because it doesn't go from 500 to 1,000 pages in the first rewrite. Okay? So you're going to try different values for t. So you're going to put in your calculator 500, well, even better, what you're going to do is you're going to put 1.1 and you're going to put the number 7 in. 1.1 and 7. You're going to hit enter and you're going to times 1,000 or times 500. And you're going to see if that number is 1,000 or not, or close to it. Okay? So you guys are trying a few of them. I don't even have the answer on my page. I have to too. So I don't know, maybe I can look that which was the right number. I don't know. 500 times 1.1. I'm going to try to the 7th. Okay, so if I do it to the 7th power, it's 975, or 974.35. Almost 975 pages. But if I do it to the 8th power, I'm definitely going to have more than 5, just so you have. I end up with 1,072 pages. Okay? So it works out that right here, this t can be 7. I found out T can be 7. So I can actually have 8 editions of book. And the reason it's 8 is because I have the original edition plus, plus 7 additional ones. That's what the 7 is doing. 7 is telling me how many times I get to additionally read this book. So I can have 8 editions of the book. Okay, so do you want to see how you can do it from a table point of view? Okay, if you do this from a table point of view, what you can literally do, take your calculator, again, it's a calculator over here. Okay, your first book is 500 pages. Whoops. Let's write this way. Here's my original books. This is the first edition, and it has 500 pages, not 5,000. And then I can take my second edition, and what I do is I take that 500 and I multiply it by 1.1. The reason I multiply it by 1.1, it's not because there's a 1.1 over here, but the reason the 1.1 happened is because the 1 in the 1.1 is the original amount of pages of the book. The 0.1 is the 10% increase. Okay? So you get 1.1 to represent 1 is the original 500 pages, 0.1 is the percentage that goes up, the 10%. So if you grab your calculator and you take 500 times 1.1, you get the second addition is 50/50. That's not right. 55, too many numbers here. 550. There we go. 550 for your patient. Okay, but then we do the same thing again. So we do our third edition. We take the 50/50, that's our previous edition, and we multiply it by 1.1. As we're working this, we need to round to a whole number of pages because that's reasonable. Okay? So what is 50/50 times 1.1? 605? Okay. I'll do one more line of this and then I'm going to leave the rest as an exercise to the reader. We take the new book number from the previous edition, 605 pages. and we multiply it by 1.1. We get,
165.5.
okay, so 666, terrible number, we'll write it anyway. And we keep going, right? And we keep going until we get something very nearly to 1,000, which we were done, or slightly over 1,000, which would be one step too far. Does that make sense? All right. All right, last problem. It's one of my favorites. So, because of the recession, the value in a new house depreciated 10% each year, for 3 years in a row. Then, for the next 3 years, the value increased by 10% each year. Did the value of the house increase or decrease in that span of 6 years? Explain. So, the natural inclination is to think, well, it increased 10% 3 times and it decreased 10% 3 times, whichever order it happened in. Well, it should just be the same value you started with. And that sort of seems like what might happen. So we're going to play around with the numbers and see if that's what really happened. It doesn't tell us how much the house is worth, right? So we're just going to make it worth something and see what happens to the numbers. So we're going to work with a nice, easy whole number of a $100,000 house. Okay? $100,000 house. So let's say that the cost of the house was $100,000. And we're kind of going to do what we were doing in the last slide when we were doing that table at the end. Okay? So this is the beginning, and then we're going to say year one. So in year one, it goes down 10%. So I take my $100,000 and I decrease it by 10%. So what can I do to show a decrease of 10%? There's two different things I can do. Okay. What could I do to find the decrease of 10% with the house is more than 1 year? Okay, I could find what 10% is, right? Of 100,000, I can subtract it. Yeah. So what is 10% of 100,000? 10,000, and then 100,000 minus 10,000 would be 90,000. Okay, so you could find 10% and then subtract. The other thing you could do is you could multiply it by 90%. I like multiplying with 90% because it's a one-step operation, and I'm going to use my calculator pretty soon here anyway because the numbers are going to get less manageable. So it's just one step to do it that way. That's where I tend to go. If you want to do this, multiply by 10% and subtract, it's okay. It's no problem. Either way, I get $90,000 in the value of the house, right? So after the first year, the house is only worth $90,000. Believe it or not, you probably did not pay $10,000 worth of the value of the house. Now you are what we call upside down in your house, right? As for people talking about upside down in their car, the same things happen with this recession with the housing market. Year two, same things can happen. I'm going to take my value of my house, which currently is $90,000, okay? And it's going to decrease by 10%. Well, again, I can find out 10% of that, which is $9,000, right? And subtract. Or I can find out 90% of the value that I currently have, either way. And what would I get? 81,000. Again, either way I do it, I get 81,000. It decreases one more year because it says it decreases 3 years in a row. 3 years. So I start out with 81,000. I could find 10% of this, which would be 8,100, and then subtract. That would be fine. Or I can find 90% of this by multiplying by 0.9. And what is the value of my house either way? $172,000. All right. $72,900. And we have some homeowners that are none too happy about this. Bought the house for $100,000 and 3 years later it's only worth $73,000. That's a bummer. Thankfully, though, over the next 3 years, it's going to go up in value, right? So, year four. Finally, good news, the housing market takes a turn. Instead of it decreasing by 10% this year, it's going to increase by 10%. Okay, so, again, you could multiply this by 10%, which would be $7,290, right? $7,290. You could add that to the 752,900. Or you do it in one step. What can we multiply by? 1.1. Okay? It's 1 because it's the original price and it's 10% more, so we get the 0.1. Again, one step, I like that. So what do we do with 72,900 when we multiply by 1.1? What do we get? 80,000 to 190. We're moving in the right direction. That's good news for these homeowners. We got a couple more years to do though. Year 5. Okay, so we take that 80,000 to 190, and we're going to increase by 10%, so we'll multiply by 1.1 again. And 88,290? 209, 209? All right, one more time. Year 6, I'm going to take the 88,209, multiply by 1.1 for the 10% increase, and what do I have? 030? 97,000. And that's the end of my time. Increase, decrease 3 years, increase 3 years. And then the question we have to ask ourselves is where we are now. Because that's what they actually asked. Did the value of the house increase or decrease in 6 years? It decreased, didn't it? As a matter of fact, this explain business, remember, we actually were the ones that created this $100,000 house. I would like to know how much it decreased. And it decreased by the new value of the house, which is $97,030, divided by the original value of the house, $100,000. Okay, this is kind of like what we did in the interest rate problem where you're comparing the passbook and savings accounts and the mutual fund or something like that, I don't remember, but those different accounts. We take the value that it currently is, divided by the value that we have now. What do we get? What number do we divide? Someone divide for me? 0.9703. So it actually maintained 97% of its value, more or less. So how much did the value of the house decrease? 3%, right? So it is worth, oh, that's my dollar amount, sorry. Mistake. It's worth 97% roughly of the original value. So it lost 3% value. And the nice thing that happens when we turn it into a percentage at the end is that it wouldn't matter if I chose to pretend like I had a $100,000 house or a $50,000 house or a $225,000 house. The percent at the end when I divide current cost after 6 years by the original cost will all end up being 97%. Okay, because we were the ones who picked, well, I was the one who picked $100,000, right? I picked that. So this is the idea to be able to compare it. You've got something concrete you're working with that is a $100,000 house, but then you're generalizing it so that it doesn't actually rely on what you